Hello everyone, in this video I'm going to talk about analysis of variance, particularly one-way Anova. So what is analysis of variance? In statistics we usually gather samples, and in the samples is actually a pool of scores of each individual participants, and these scores we usually find the mean to know that what is the average score of the sample. And that is usually not enough because we would like to also understand about the distribution of the scores. So we calculate the variance, and it is actually the average distance of the scores from the mean. Why do we calculate variance? Because we wanted to know how far each scores from the mean. In other terms, whether it is close or is it far from the mean. In reality, you will never get all the scores same as the sample mean, because there are high chances of variation, meaning the scores of the participants will be different to each other. In some cases will be similar, in some cases will be different. So why actually the variation exists? It's because our sample consists of people. So if people, you cannot expect everybody to respond in the same manner. There might be some differences in the way people respond to questions. So their scores would not be identical for every participant in your sample. So there might be some who got the same score, some might get different scores. So when you talk about people, there are a tendency of people producing errors in the responses. Or people might also have some advantages, and that's why they respond in a particular manner. So what do we mean by producing error in responses? Meaning on the day of the experiment, on the day that you conducted the study, the person or participant might have some mood disorder, or might have been a bad day, or had failed an exam. So what would have happened is their scores would have been influenced by the mood. So they did not answer truthfully, or they did not give their best responses. So that could be an error. But in some cases, the scores would be different because they have advantages. What type of advantages? Maybe because that particular group or an individual has just received a treatment. So, or maybe went for a mood therapy. So his mood was really good. So when you administered the test, their scores was higher compared to the other person. Or maybe he belongs to a specific group. So for example, he might be maybe boys scored a higher score than the girls because the question that you asked was about football. So the boys would have had understanding about the football, so they have given a higher score compared to the girls. So there is a lot of reasons why the reason a variation exists in the group. But mainly they can be grouped into whether it is an error that is being produced, or is it because there are some advantages that happens in the data. So this is actually what the analysis of variance is trying to say, because when we look at the variance, when you have a distribution of scores, what we are trying to do is we are trying to find out the source of variation that exists in the data, why the variation actually exists. So with this analysis of variance, we are able to identify where exactly the variation is coming from. Okay. So what is this one-way Anova actually used for? One-way Anova is used to compare means of two or more independent groups in order to determine if there is any statistical evidence that is associated. Population means are significantly different. So basically we are trying to say if you have more than two groups, and if you want to see if there is any mean differences, you conduct a one-way Anova, because as we remember, t-test is used to compare means between two groups. So if you have more than two groups, you run a one-way Anova. So in Anova, we are seeing whether there is any significant difference between means of more than two groups or means of two or more than two interventions, treatments. So the groups or the treatments might vary. So it can be three groups, it can be four groups, five groups, depends. So in Anova, there are also two types of variables. There is one called independent variable, there is other one called dependent variable. Independent variable should be a categorical variable and should have more than two groups. The dependent variable, this is the outcome variable, should be a continuous variable. When there is only two groups, we conduct an independent t-test, as I mentioned. Since we have more than two groups to compare, we no longer use means, but we use variances. So how do we actually do it? In Anova, we examine the variability. Just like we mentioned in the previous slides, what we do is we find the variability of the data, and we would like to know if any patterns exist in the variability. And if there is a pattern exists in the variability, is it because of the groups that exist? Is it the group is causing the variability? Meaning, is there an advantages of the group members that is causing them to be different compared to others? So what we are doing is we are trying to find the total variability and divide them into between group variability and within group. So in Anova, we are trying to address the average amount of difference or variation between scores. So we want to see if there is any variation in the scores between groups that we compare over the variation that exists within the score. So we are looking into whether there is how much error that exists and how much variation exists because of the advantages of being in a particular group. So we take the ratio of these two, the amount of variation between the groups, the average amount of variation within the groups. Okay, so with that we calculate the F ratio. Then we check if the difference observed is by chance or it truly happened. So basically we want to know if the differences between group is happened because there is some advantages or something that is very significant, or it just happened because they were in a particular group it just happened to have an error in that particular responses. So to determine that, we have to run an F-test. So for independent sample t-test, as the name goes, we run a t-test. Now we are running an F-test. So we are using the F distribution. Just like in t-test, we calculated the t-statistics and we compare it to the t-critical. So in Anova, we are looking into estimating the F ratio or the F statistics and compare it with the F critical. So how do we get the F critical? Using the alpha and also the degrees of freedom. So we compare F ratio to F critical to make a decision. So we accept the null, then we say there is no difference between the groups and we just report the result. But if you reject the null saying there is a difference, we have to find out where the difference exists between the groups. So we have to run a follow-up analysis and report the results. So let's look at an example. Let's say that you're interested in examining the difference in salary per hour between three major ethnicities. So you want to know if there is any differences in the salary between Malay, Chinese and Indians. So here the independent variable is the three ethnicity groups, and you have Malay, Chinese and Indian, and the dependent variable is the salary, which is a continuous variable. So following is a made up data of 15 participants. So we have 5 Malay participants, 5 Chinese and 5 Indians. So this is their scores. So this is actually the pool of the data. So this is the pool of the data. So the blues represent the Malays, the green Chinese and the red are the Indians. So with this pool of data, this entire 15, we can actually find the total variability or the total variance. So how do you calculate the variance? It is the average squared distance of scores from its grand mean. How do you calculate that? So total variance is the sum of squared distance divided by total number of observations. So what is sum of squared distances? So you are going to find the mean of the entire pool of data, which is labeled as the grand mean. How do you get your grand mean? You add 7 plus 7, 8, 9, 9 until 6 and you divide by 15, you get your grand mean. Then to find the total variance, you subtract the grand mean from the individual scores and then you square it and you get the square difference between the scores to the grand mean. So how far is each of the scores from the mean? So this A until O is actually the distances. How far is each score from the mean? Then you square it, you add them up and you divide by 50, you get the total variance. And as we said in Anova, there are variability that exists. So here we would like to break the total variance into variance caused by the group. So there is group 1, group 2, group 3. So which is, we call it between group variance, the average squared distance of groups mean to the grand mean. So we want to see how far is this group mean to the grand mean. How do you get the group mean? It is the group of Chinese. And how far is it from the grand mean? You see here there is also the mean of the Indian group and how far is the mean from the total or the grand mean. And this is the Malay group's mean to the grand mean. So it actually tries to tell us the variability between the groups. So is there any differences, variation in the scores between Malay, Chinese and Indian? And there is another source of variation that exists, which we call the group within group variances, which is the average squared distance of the scores to the group mean. So what we are trying to see here is how far is each score to their group mean. So is there any variation within this group, within this Malay group? So we find the mean of the Malay salary and we see how far is each individual salary from the mean of that particular group. So for between group, we see how far is the mean of the groups to the grand mean. In within group, we see how far is the scores to their group mean. Okay, so once you get the variability between the groups and the variability within the groups, we can take the ratio of it. So the average amount of variation between groups over average amount of variation within groups, you get the F ratio. So what exactly that we are doing here? We are trying to find the total variation, the variability in the data, and we split it by variation between groups and variation within groups. So the total variability, we would like to split them into two. We want to see how much is attributed by the group and how much is attributed within the group. So for the variation between the group, we want to find the mean squares between. So what is the mean square between? It is actually the sum of squares between divided by degrees of freedom, because we mean squares between is actually the average of the square differences between the groups. And for variation, we find the mean squares within, and for that we need to have sum of squares within and degrees of freedom for within. So once we get that, we are able to calculate the mean square between, which gives us the variation between groups, and the mean squares within for the variation within groups. Let's look at the map. So in this slide, I'm going to show you step-by-step procedure to estimate F ratio and F critical. So the hypothesis for this example is there is no significant differences in students' exam score between groups of people who took memory drug, placebo, and whom did not receive any drugs. So there is 3 group of individuals, and we want to see if there is any differences exist in their exam scores. So what is the first step? We need to compute the mean of each group and the grand mean. So we have to calculate the mean of this group, group 1, mean of group 2, mean of group 3, and we have to get the mean of the entire data set. So the mean of G1, 83.4. How do I get this value? Is I add 70, 77, 83, 90 and 97 and divide by 5. So I get 83.4. So the grand mean is how I get my grand mean. I can add all these 3 group means and divide by 3. The second step is I need to compute the sum of squares. Sum of squares is the squared distances from the deviation from the group or from within the group. So how far is the score from the grand mean or from the group mean? Okay, so for the between, I have 2 sources of variation. The variability that happens in my data is could be because of the groups that they belong in, or because of the people, the within the group or between the group. So that is what we mean by the source. And the formula is for between is you find the mean of the group, K represent the group, mean of the group minus the grand mean. Then you square it and multiply by the number of cases that you have in that particular group. Okay, example, here we have the first group, the mean of the first group was 83.4. Subtract the grand mean, which is 50. We take the square and multiply by the number of cases. We have 5. We have 1, 2, 3, 4 and 5. Then we add it with the second group. The second group mean minus grand mean, square it, multiply by 5 and so on for the third group. So how do you get the within group variance? You have to subtract the individual score from the particular group to the mean of the group. So here the first score is 70, the group mean is 83.4. So 70 minus 83.4, you square it, plus 77 until the 97th score with the group mean. Then you add with the second group, 37 minus 50. So the second group score to the second group mean and then square it. And you do it until the last score and you repeat it for the third group. So when you add these two variation, which is the sum of squares for between and within, you will get the sum of squares of the total. Because remember, the initial idea is the total variation. We want to partition it out. We want to see how much is being attributed by the between and also by the within. So the third step is to compute the degrees of freedom for each source of variability. So for between, the formula is k minus 1. K is number of groups. In this case, you have 3 groups, 1, 2, 3. So the degrees of freedom will be 3 minus 1, so 2. Within is going to be n minus k. N is total number of cases you have minus number of groups. So in here, we have 15 cases or 15 observation. Minus number of groups, we have 3 groups, so becomes 12. So the total degrees of freedom is n minus 1. N is number of cases, number of observation, 15 minus 1 is 14. So it gets 14. So even if you forget this formula, degrees of freedom for total is a summation of between and within's degrees of freedom. So 2 plus 12, you get 10. So what is step 4? So once you get your sum of squares and degrees of freedom, you calculate the mean squares. So mean square is for mean square between and mean square within. So mean square between is actually sum of squares divided by the degrees of freedom. So just now we calculated the sum of squares and then we divided by degrees of freedom of 2. So for within, this mean square from within divided by degrees of freedom for within. In step 5 is you compute the F ratio. So once you get the mean square between and mean square within, you can use it to find the F ratio. In step 6 is you have to find the critical F critical for alpha 0.05, degrees of freedom for between and within. Once you get your F critical, you can use F ratio to compare it to F critical in your hypothesis. So the summary of computing ANOVA manually, we need to identify all the required information to compute ANOVA. What are they? The mean, sum of squares, degrees of freedom, mean of sum of squares, between and within. So once you have that, use the formula to compute the F statistics. Once you have this F statistics, compare it to F critical. Where do we get this F critical? From the F table, using the alpha value and degrees of freedom for between and within. Now, once you have F statistics that is less than F critical, then you find there is no significant differences between the means. Basically, the means are the same. So that's the end of the analysis. Just report it and interpret the findings. But when the F statistic is larger than the F critical, meaning there is a significant mean differences. So once there is a significant mean difference, you need to do a follow-up analysis. So this follow-up analysis will start with the estimating the effect size. How big is the effect? When you say there is a difference, how big is the difference? And then you follow up with post-hoc analysis. You want to know where this difference exists. Remember, we have more than 2 groups. So which pair of comparison actually has higher or lower mean? So where does the differences actually exist? Between the first and the second group, or the second and the third group? So we need to identify where is it. So after this post-hoc analysis is when you end the analysis and interpret it. This is the basic terminologies and the list of commonly used abbreviations in one-way ANOVA or in ANOVA. So please look into it. Thank you.